Okay, so this is the video I was telling you about, what we did yesterday to remind you or to help you think about, to help you determine what is a function and what is not a function. Okay, now, very important facts. Fact number one, all functions are relations. If you say this is a function, then it is also a relation. All relations are not functions. That is fact number two. Okay? So, why am I saying that? Just because you can write all the points, x, y, x, y, x, y, does not make it a function. Now, if I give you a relation like 2, 7, 2, 9, 2, 15, 2, 15, 2, 27. So this is a relation. Now let us check if it is a function. For you to check if it is a function, you must do mapping. So we are checking if it is a function, we're going to do mapping. You're going to draw your domain and you're going to draw your range diagram. So you're going to write here domain, you're going to write range. You're going to arrange your domain from least to greatest without repeating. So here, what is our domain? All our x values. And if you notice, all our x values is the same. So it is 2. And then we have 7, we have 9, we have 15, we have 27. 2 goes to 7, it goes to 9, it goes to 15, and it also goes to 27. And this is not a function. It is a relation, but it's not a function. So what are you going to say? This relation is not a function because one domain has many ranges, has more than one range. What determines if a relation is a function is the mapping. You must do the mapping and then you decide whether it is a function or not. Okay? And now let's do examples. So here I have my questions. So it says here, determine whether each relation is a function. Explain your answer. Okay, so I'm going to do mapping for this one. So I have 7, then I have, no, I'm supposed to arrange 7, 6, and 5. So it is 5, 6, 7. This is my domain. Then I'm going to do my range. Make sure these corners are curved. They are not supposed to be 90 degrees, supposed to be curved. So this is my range. My range, my smallest range is 2. So 2, 3, 4. 5 goes with 2. 6 goes with 3. And 7 goes with 4. Each domain has only one range. Function, yes, because each domain has only one range. Has exactly one range. Each domain has exactly one range. This is my explanation here. Okay, now let's do this one. So I'm gonna draw my map, domain, my range. My domain is 15. It's the same one. My range is -2 is the smallest, and then 0. 15 goes to -2, 15 goes to 0. No, because one domain has more than one range. So when I do this one, so I'm gonna draw my map, domain, my range. I'm gonna arrange so it is 0 and 2, 0 and 2. The other one is also 0, my x's. Then my range is 1 and 3. 0 goes to 1, and 0 goes to 3, and 2 goes to 1. Function, no, because one domain, which is 0, has two different ranges. One domain has two different ranges. Okay? Or you can say one domain has more than one range, like that. Okay? Determine if a relation is a function. So draw your map, your mapping diagram. This is your domain. This is your range. My smallest is -1, 0, 1, and 2. Then 8, 15, -4, and 0. -4, 0, 8, 15. -1 goes to 8. 0 goes to 15. 1 goes to 4. No, 1 goes to -4. And 2 goes to 0. Yes, it is a function. Because each domain has exactly one range. So there. This one I can see already. Just by looking, I already see. -2 has 7, -2 have 3. This is not a function. Because -2 has two different ranges. Okay? Even this one is not a function. See? This is not a function. This is not a function because 2 has 1, 2, 3, 4. 2 has 4 different ranges. But draw your map. Don't do like me, draw your map. Alright, now this is when they gave you the relation as points. So what if they give you the relation as a table? Every x has a y. There is no x repeating, yes. Yes, and then you say, because each domain has exactly one range. Remember, this is your domain, this is your range. And you map. You can map right there. Or you can map by yourself outside. So you see, already this is wrong. 2 goes to 0. So this one, I would rather do the map. So you see. So you have 2 and 3. This is your domain. And then this is your range. 0, negative 1. No, negative 1. Then 0. Then negative. Let me do it again. I'll do it down here. Domain is 2 and 3. And our range. Negative 4, negative 1, 0. Your range from least to greatest. 2 goes to 0. 2 goes to negative 1. 3 goes to negative 4. And because 2 has 2 different ranges, not a function. Okay, and you explain this is not a function because 2 has 2 different ranges, negative 1 and 0. It's supposed to only have one range. This one, it is a function. Yes. So I'm going to draw my map, domain, and range, 33, 35, 36, 8 and 10, 33 to 10. Sorry, 33 to 10, 35 to 8, 36 to 10. Each one is going to its own range. Yes, this is a function because each domain has exactly one range. So you see, these are all relations, but this is not a function. All of them are relations, but this is not a function. Okay? See, all of these are relations, but look, these two are not functions. Okay? So not all relations are functions, but all functions are relations. You have to remember that. Let's look at this one. You have this. Is this a function? And then what did they say? No, the relation is not a function. An x value has more than y. So because 1 goes to 2, so if you draw your map. Drawing your map helps you. You have to draw your map. Draw your map for every question. So here your domain is 1, your range is 2 and 3. 1 is going to 2 and 1 is going to 3. So you say, no, the relation is not a function because 1 has more than one range. Or the domain has more than one range, like that. Now, if you look at this one, the same thing. Yes, they said yes. So let's prove that they are right. Domain and range. 1, 3 and 5. I'm arranging my x's. And then 2 and 4. 1 goes to 4. 3 goes to 2. 5 goes to 4. Each has its own range. So yes, it is a relation. We are correct. Look at our diagram. Now, no, this is not a relation. First of all, they didn't do domain range. So according to this map, negative 2 has 0 and negative 2 has 4. So that's why it is not a function. No, it is not a function. All right. Then you have this one. So this graph is a function. Why? The vertical line touches the graph only one place. See, if I draw another one here, it's only touching the graph one time. Look, All my vertical lines are touching the graph one time. Here, no, look. There's this point and this point. Those are 2 times. There's this point and this point. Those are 2 times. There's this point and this point. So this is not a function. So all of them are relations, but this one is not a function. You do the vertical test. You take your pencil. This is what I meant by pencil test. If you put your pencil, you want to see how many times your pencil is touching the graph. And if you see, my pencil is touching the graph 2 times. Even this one is not a function. Not a function. If I drew my vertical line, see, it's touching 2 times. Look. Even the y-axis is touching the graph 2 times. Same thing as this. Not a function. So the only one that is a function is D. This one here. This one is the only one that is a function. Function. Okay? And how do you explain when it's not a function? Because one domain has more than one range. Not a function because one domain has more than one range. Okay, that's it. So here, let's look at this one. Which graph represents a function? This one does not, because we said all vertical lines are not functions. We've already seen a circle is not a function. This is wrong. So not a function. Not a function. Let's look. Let's do the vertical test. It's touching 2 times, so not a function. So my answer is this one. If I do the vertical test, my vertical line only touches the graph 1 time. Which relations represent a function? This one is wrong because of 0. 0 has 2 different y's. This is wrong because of -7. This is wrong because of 6. Every x is different. So yes. Question this one 4. There you go. I know just by looking, but I should be able to do my map. If I do my map, domain, -6, -3, 1, 6. And then my range is who? I have 2 and 5. -6 goes to 5. -3 goes to 2. 1 goes to 2. 6 goes to 5. Each domain has its own range. So 4 is correct. I think I've done all. Let's do graphs. Maybe more graphs will help. The table, you just have to do your ranges. But I already can see this one and this one, not a function. See? Even -1. These domains made this not a function. Here, I have all different x's. Yes, so this is a function. But they said we have to explain your answer. So you have to, for you to do, you must do your domain and range, please. You must do your mapping, domain and range. So -2, -1, and 0. And then you have -1 and 1. So -2 goes to 1. And -2 goes to -2 goes to 1, -1 goes to negative 1. No, this is a function. I can see that. Negative 1 goes to negative 1. Negative 1 goes to negative 1. Okay. And then 0 to 1. No, this is a function. See? This is why you have to do your domain and range so that you don't make a mistake. You must do your mapping. This is your function. Yep, this is a function. Because each domain has its own range. Okay? Yep. Let's do this. This is a function. This is definitely a function. So my domain, I want to arrange negative 6, 0, 2, 3, 5. And do my range. Negative 3, 0, 1, 4. Negative 6 with 1, 2 with negative 3, 0 with 4, 3 with negative 3, and 0 with 4, 0 with 4, okay, I did 5 with 0. So this is a function because each domain has exactly one range. You write that. Each domain has exactly one range. If I do this, even this is a function because every x has its own y. See that? Even this function. So I'm going to do my mapping. So negative 6, negative 1, 0, 1, 6. Remember, you have to arrange from least to greatest. And then this is your range. What is this? Negative 2, negative 1, 2, 3, 6. Negative 6 goes with negative 2. Negative 1 goes with 6. 0 goes with 3. 1 goes with negative